Ladies and gentlemen, feast your eyes on the finest four-jaw chuck money can buy. You were probably expecting like an F or a G, but no. This is an H. I've wanted a smaller four-jaw chuck probably ever since I got the lathe. And then when I finally did get this, it spent a long time playing musical chairs around the shop, just getting moved from one place to another. Just always seemed to be in the way. I was essentially avoiding making the backplate that I needed to actually mount this thing on the lathe. But I woke up this morning, looked myself in the mirror and said, "This old Tony, today's the day." So if chuck backplates are your thing, you've come to the right channel. Now my lathe uses an American L0 spindle. And I seem to recall at the time checking places like eBay quite often for a small 6-inch chuck with an integrated L0 mount. And I really couldn't find anything that looked like it was even in halfway decent condition. So I bought this one. This is new, it's import. And now I need to make a backplate in order to attach this to my lathe. You can sort of see the backplate here where the backplate ends and the chuck begins. Now I've made a couple of these in my time. There's really not all that much to them. They're just a pain in the butt. First, I'm going to have to find a large enough piece of material to hog one out of. Then there's boring and cutting the taper, of course. And from what I recall, that just involved a lot of putting the chuck and the backplate on and off a million times until that fit was just perfect. The L0 tapers also require a key. And then there's just some big threads. So the first order of business is dig through the cutoffs pile and see if I can find a piece of material about 6 inches in diameter and, 2 or 3 inches thick. The only real candidate that I have is this thing here. So as usual, I'm not exactly sure what this thing is. I think it's a low to a low-medium carbon steel. The only thing I do know is that even though I'm constantly cutting slices off this, it never gets any lighter. Now, word on the street seems to be that chuck backplates should be made of cast iron. And I'm not really sure why that is. The few backplates that I have made, I've always made them out of steel, and I've never had any issues with them. The cast iron may be an issue with maybe purely threaded spindles. You know, like thread galling or seizing. That might be reduced by going to a cast iron, like a dissimilar metals sort of thing. But beggars can't be choosers. Now I'm going to need a nice thick slice, about 2 1/4 inches. That should leave me some breathing room for some cleanup. Now, if this thing had only been about 2 inches smaller, I could have cut this in my saw. I'm going to have to figure out another way to get this thing off of here. Given my unfortunate lack of options, I think the only thing reasonable to try is the Bruce Lee 1-inch punch. Okay, well that looks pretty alright. Remember, that's all in the hips. Got to come from your core. Though that did wander a bit. Not the straightest thing in the world. That's what I get for worrying too much about the camera and not concentrating on my chi. I'm going to pay for that in the lathe. I'd like you all to meet my spindle nose. As I mentioned earlier, this is an American L0 taper. It's got a key in there, and then a big captive ring that helps pull and seat the chuck or the faceplate onto that taper. Now before I mount the four-jaw, I want to pick up this taper angle. I'll be cutting that taper with the top slide. It's short enough taper that it's not really a big deal to top slide it instead of setting up something like the taper attachment. Okay, so I'm sure you've seen this before. I've got an indicator in the tool post exactly to the center height of my lathe, and I just eyeballed the tip of that indicator to the tip of a center in the tailstock before I moved over to the spindle nose. You'll notice I'm setting up on the back side of the taper instead of up here in the front, and that's simply because when we're cutting the female side of this taper in the back plate, that will be flipped around, right, pointing towards the tailstock end. And because my boring bar is cut on the operator side, I want them to travel in that direction, cutting the inside of that taper. And this angle here is on that side of the spindle nose. In the interest of making sure this horse is dead, the whole point of this is to set the top slide to the same angle as the spindle nose. So the taper the top side is going to cut hopefully will match the taper on the spindle nose. And because I'm not Uri Geller, I'm using an indicator to dial that in. I'll spare you the details, but this process is very tedious. This took me probably 20 minutes to really get it in there, screwing around with a soft hammer and, tightening the top slide, and then it moves and then loosen it again. I mean, there are a couple of dips and small dings. It's not the freshest spindle nose in the world, but I'm going to call that good.
Yeah, maybe.
Now, no matter how I set the tool post, the top slide is always going to cut that taper or cut that angle, right? Even if my tool is back here and I turn this handle, it's going to trace that taper. Now, I apologize if that came across as painfully obvious, but I thought I'd just get it out there because it's going to become important when we set up to cut the threads. Now, you could have set up that spindle nose taper without reading directly off the spindle nose. Look up the numbers in the machinery's handbook and set the top slide up with indicators and sign bars and angle blocks. Or I suppose if you're trying to make some kind of spindle adapter or backplate for someone else's lathe, I don't know, maybe your Mother Teresa or something, you could have set it up without having the spindle taper in front of you. Yeah, that's probably as good as it's going to get.
Maybe.
Although I do have quite a bit to take off of here. This is more to minimize how much my lathe is going to be trying to dance across the floor. All right, so it's all set up and ready to go. I can start to rough this out now. I did set up a center in there. This probably isn't strictly necessary, but because this surface isn't flat, I'm going to have somewhat of a violent interrupted cut until I flatten it out. Better to have that there and not need it than need it and not have it there. All right, get to it already. It's not going to turn itself. All right, so I've got to get this down to about 4.5 inches, to about an inch, inch and a half deep or so. I'll have to double check. So I'll catch back up with you in a couple of weeks. I've got the boss to final shape. This is where the threads will go. There's the thread gutter in the back. And I've bored it through. Now it's time to cut that internal taper. Now tapers can be a little bit funny, not ha-ha funny. It's best to get a good night's rest before you try to cut one. Here's my version of the powered top slide tool. I think everyone's probably got their own take on this thing. That just goes into the center drilled hole in that top slide bolt, and then I can power it with the cordless drill. For my lathe, this style seems to work better. With a socket on there, it would unscrew that nut. And this one's also good for vampires. You're not going to see this while I'm cutting the taper, but off camera, this is basically what's going on. Okay, I've got the carriage locked. The diameter of the taper, or the depth of cut, will be set by the cross slide, and the taper obviously gets cut by the top slide. So that, in theory, is an L0 taper. Ended up with a little bit chatter down in that inside corner. All right, so now I'm just going to go in there and cut some clearance, maybe 100th thou. As it's cut now, the spindle nose would fit, by the time it hit the tape, it would hit the taper and bottom out at the same exact time. I want that taper to hit first every time, so I'm going to take 100th thou off the bottom. I think that's about all I can do. I cut some relief in the taper wall there, so the spindle nose doesn't have to kiss off on that entire surface area. And I just broke some of these corners while I was in there. I guess it's time to try the threads. This darn thing is looking a little bit short though, but yeah, that's what the numbers say. This darn thing is looking a little bit short though. Alright, I'm all set up to cut the thread. I've actually already done a quick scratch pass to make sure I was cutting the right pitch. I've got the thread cutting tool in there. It's square to the work. The top slide is over 29.5 degrees, and both the dials are zeroed out. Now I see that question come up a lot online, the whole 29.5 degree thing. There's not really much to it, but it does seem like it's a source of confusion. We can take a look at that in a minute. I just want to get this thing cut. But 29.5 doesn't have to be exactly 29.5. Like if it's 29.49 or 5.1, that's totally, just kidding. As long as it's a hair less than 30. It should be fine, and we'll look at why that is in a second. So I'm not going to go through every step here. There's plenty of videos on thread cutting online. I think there are. It's a 60-degree thread, 4.5 inch by 6 TPI. Again, my carriage is zeroed out, my cross slide, sorry. And that's going to be my reference point. I'm never going to touch that. I mean, I'm going to use the cross slide to pull the tool away and then use its zero mark to get it back in the same position it was where I left off. The depth of cut is all going to happen on the top slide. All right, I'm going to start to rough this out, and it looks like we're getting close. I'll break out the wires. We'll start taking some measurements. I am getting some chatter though, as that tool has gotten in there pretty deep, but those threads are almost cresting. I'm just going to hit that with a little triangular file and we'll take a measurement. Okay, so thread measuring wires. My set happens to be a PD. I'm sure they're all the same. There's 16 sizes, and you get 3 of each. And it comes with a conversion chart, a thread chart, to use the wires. These are for 60-degree threads. The conversion chart is for if you wanted to measure metric threads with these inch-size wires. There's also a little chart for Acme screw threads. And if you haven't used these, you just select, find the thread you're trying to measure. In this case, it's 6 threads per inch. And it tells you which wire size to use, 092. And there you go. You lay them over the threads and mic over the wires, and there's a little formula that tells you what that size is. Now, there are other ways to measure threads. I've just always used the wires and happen to like them. And I don't know why everybody complains about these things. You just put 2 on one side, 1 in the other, and then measure across the top with your mic. So for the price, it really doesn't get much easier than that. Now in this case, I don't need to use any formulas because I could just use these same wires on the backplate in the lathe. And if I hit this measurement, I know that it'll thread onto the captive nut. So now hold on just a minute. I have no idea what that is you're looking at in the camera, but it's not what I was looking at in real life. Stick with it just a minute until the camera angle changes before you hit the unsubscribe button. But it looked nothing like that car accident you're looking at on the screen. And if for some unfortunate reason you don't have 3 hands, just use some grease. I said some grease, not a ton of grease. Looks like I have about 42 thou left to go. Alright, so according to the wires, I'm within about 2 thou. I'm just going to try to clean it up with a file because that chatter just looks terrible. Alright, the triangular file helped a bit. I'm going to go out on a limb here and call these passable. I'm still not sure why those chattered so much. I did put a radius on the threading tool, just so the root wouldn't be so sharp. Maybe that radius was just a little too big for the size of threading tool. Probably not a bad idea to clean this key up while I'm here. Well, nuts. I'm barely catching that thread. I've got maybe a thread and a half of engagement. I knew something seemed fishy. I mean, it looked a little bit small. I'm going to have to set that back up again and open the taper just a little bit. It doesn't take much on diameter to get it to translate up that taper. Well, ain't that something? Alright, that's a lot better. There's just one last thing I want to check though. You're not going to be able to see this because I can hardly see it myself. I've got some 1/16 TIG wire with just a little bend in it, and I'm feeding it through into the bore and trying to measure the distance between the end of the spindle nose and the inside of this backplate. I can't get the 16th in there. That's 60. Let's call it 60 thou. But I have some 30 thou wire. This does fit in there. I just want a little bit more gap at the end. That's starting to get a little bit tight. If I end up with a chip or something in there when I mount the chuck to the spindle nose, it could potentially cause problems. Alright, that's a little better than before. I've probably got about 50 thou in there. I can just get the tip of this to stick. It'll have to do. If I come out any further, I risk losing the register that needs to be machined on the front of this. Last thing I want to try is bluing it up. Pro tip, the thicker you lay the stuff on, the better your tapers will match up. Alright, here goes nothing. So I don't know if you just saw that. I've completely backed up the captive nut. The back plate is still tight. I think that's a good sign, like that taper has locked. And now I've got to tap that captive nut just a bit to knock it off. Though keep in mind, this wouldn't be the first time I've spoken too soon. So I don't know how well you're going to be able to see this. It's pretty faint. I do have blue on the top and the bottom, a little bit more on the top, the back of the taper, than at the front. This could use a little fine tuning with some sandpaper or like a small rounded stone. But I'm going to call this good for now and go ahead and cut the keyway. I haven't bothered to completely clean it up because this still needs to be taken to size. A lot of this material is going to come out when I fit this to the chuck. I'm going to cut the keyway in the shaper. I've locked down the clapper box and I've got this sort of homemade tooling for cutting keyways. It takes 10 millimeter square high-speed steel that are just ground into different size and length of slotting tools. They're just inserted and tightened down from the front. I also have this angle plate. It's probably one of the first things I made for this shaper. It's got a large cutout to accommodate different tool clearances and diameters of work. I'll bolt that on. And then I intended to bolt this in with the taper facing the machine, but it looks like it's not really going to fit. Maybe I could do it this way. I don't know if I have enough clearance. Yeah, that actually looks like it'll work. I think I'll set it up this way. I'm pretty sure I've mentioned this before. This is an Ohms 300. I don't even know if I'm saying that right. I've never seen another single piece of machinery in my life with that brand on it. It has 8 speeds via 2-lever gearbox. I'm currently running at 60. That's strokes per minute. Usually I'm down in the 35 and 45. I don't think I've ever run it much over 60. And you really don't want to see this thing running at 150 strokes a minute. I have no idea what that's used for. So I've gotten it set up and I've actually cut the first pass. And by the first pass, I mean, I don't like to start right at final width. That's a big cutter for this size machine. So I'm now cutting 4 millimeters and then I'm going to switch over to the larger tool and cut pretty close to final size. I don't have a tool that's the width of the key slot, so I'm going to have to step over left and right a bit. So I've switched to the 8 millimeter cutter. I've got a bit of a thin section here. I'm worried about blowing that out, so I'm going to take it slow. The final key width is 3/8 of an inch. You may notice that the shaper stroke's a little bit on the long side for this, but I'm just going to roll with it. I will be running it at about 60 strokes until I get through this thin section, and then I'll slow it down when I hit the actual meat of the taper. So I came down into the garage this morning with a cup of coffee in one hand, just sort of mindlessly putting some tools away with the other, soaking in the atmosphere and generally lollygagging, but getting back into the state of mind of finishing the keyway in the backplate on the shaper. When out of the corner of my eye, I caught the yellow in this chuck. What a brilliant color that is. Nobody likes changing chucks on the lathe. When you pull this off the shelf and you see that wonderful yellow color in there, it just brightens up your day. Anyway, I've been hung up about a 65 millimeter dimension that I don't know how I got into my head. For some reason, I thought the register on this was 65 when in fact it's almost 130. That's more than 5 inches. So all that heartache about breaking through with the taper on the back plate and losing the register on the back of the chuck was for naught. Let's have a look over in the shaper. You see that thin wall in there? I just needed a couple of millimeters, I thought, to register the back of that chuck. And that little bit of material has been requiring me to go to longer and longer slotting bits in the shaper. I mean, not the end of the world, but just a pain in the butt. So I'm just going to put this back on the lathe and cut that out, and then come back here and finish that slot. All right, now it's a little more like it. There's the piece that popped out as I was cutting it. It was about 4 millimeters thick. That saves me a lot of height in slotting tool, and it wasn't necessary. So if you're wondering how I got that into the same exact position, the answer is I didn't. I mean, I eyeballed it as close as possible, but that slot has yet to get to final width or final depth, though to some extent it doesn't really matter. Though in the shaper, I've never really found a good convincing way to center key slots like exactly. I mean, usually what I do is just bring the tool bit in really close, so I'm just scratching the bore, and watch that the two edges of the cutting tool scribe about the same line inside that bore. So basically two parallel lines of the same depth or width, I don't know how you call it. It's very touchy-feely. I mean, it's always gotten me, close enough for what I've had to do. But if anybody knows of a good way to actually dial that in, I'm all ears. All right, so this will be the same shtick as before. I'm going to start off with the narrower slotting tool, move over to a larger one, and then when I'm at depth, bring the slot to final width. All right, let's give it a try. I think that'll work. Let's take it over to the lathe. So I think you saw me just break some of those sharp edges off with a file. It turned out nice, if I do say so myself. The old saying is true. The only thing you can't make with a shaper is a profit. Let's give it a try. Yeah, where'd I put that key? All right, that magic moment. It's a little snug. So it looks like I went a little bit deeper than I needed to with that key slot. I think I should be all right. Now that I've got that in there, I can take the diameter down and cut the register. So it looks like a pretty decent fit. Could have probably been just a hair tighter, but I can't feel any motion at all. Once it's on there, it looks like it's a really good fit, but just by hand when I put it on, it seems like it could have been just a little bit tighter. I'd like to take this flange diameter down a bit, but I'm going to wait until the socket head screws get in there and see how much material I actually have left on the perimeter. This is easy to cut even with the chuck installed. So without a DRO, or a mill for that matter, I've had to lay out the bolt hole pattern the old-fashioned way. While this was still on the lathe, I blackened the back and used the lathe cross slide to scribe a faint line at the diameter of the bolt hole circle. I then made a punch mark, did a little bit of math, and just set my calipers to, sort of the straight line distance between holes, and then just walked my way around. Now, I don't know if you can see that on camera. It took me 3 tries to get that just right. And I've marked the drill location with just a blue Sharpie mark. So that little drill press isn't really intended for these sort of shenanigans. It was much too fast for what I needed to do. I'll let you know when your back's up against the corner. Now if that just ain't the cutest. Alright, all in all, I think that turned out pretty alright. I've now got a little 4-jaw chuck I can spin at the top speed of my lathe. I've never taken the big one up to 1200 RPM. I think that technically is rated to 500 or 600. But for smaller work, and especially for drilling and boring odd-shaped parts, this is a welcomed addition. So I think that wraps it up. I apologize, I think I mentioned maybe getting into some of that thread cutting stuff, but this video has probably gotten too long. If anyone's interested in that sort of thing, maybe just let me know in the comments and I'll do a separate installment. So that's it. Thanks for having stuck around. I appreciate the company.